B part 4, lecture 5, Poisson brackets of Q and P. They are called conjugate variables. So, item 1, I want to develop the Poisson brackets of QK and QL. They are coordinates, okay? Generalized coordinates. Number 2 is PQKPL. They are momenta. This 3 is the mix of coordinates and momentum. So recall that the Poisson bracket of two functions, A and B, is defined as, you see, this relation here. Now, attention now, I here is dummy indices, okay? This is I is dummy. It's dummy. You see? QI, it's called QI and PI are the canonical coordinates and momenta, conjugate variables, or attention now, coordinates, momentum are functions. So, and I said over, and now I'm saying over and over again. So, let's first calculation of this Poisson bracket or curly bracket. Let's apply the definition over here. Just set A equal QK and B QL. You see, you just go there and substitute. So it's quite straightforward. Now you apply the concept that the variables, the coordinates are functions. You see, these are functions. Like A and B also are functions. So let's compute each derivative. You see, partial of K, QK, PI is 0 because QK does not depend on any momentum. You see, they are independent variables. So, likewise, partial of QL, PI is 0 for the same reason. But partial of QL with respect to QI is the chronic delta. So this here is chronic delta, in which the definition we already discussed previously. Thus, plugging into the definition, you see, you just set here 0, this is chronic delta, minus delta A chi 0 and 0. So I conclude that item 1, this Poisson bracket of QK/QL is equal to 0. Now, second here, now we'll derive the Poisson bracket of the momenta. You see, apply again the definition A PQ, B PL. Then you just look at here and look at there. You see, it's straightforward. You just substitute and apply also the definition. Attention now, partial of PK PI is delta. Why? Because they belong to the same set of momenta. Okay, as I did over here, you see that's it. Okay, I'll show later. Okay, that right here. You see, they belong to the same set of generalized coordinates. These they belong to the same set of momenta. So then I can also, this is 0, okay, because they are independent. You see, now this over here is also 0. You see, they belong to different set. You see, and this again, this is delta, in this case delta Li, just set over there. So then the calculation of this this Poisson bracket is also 0. Now let's move to the third one over here. Again, you just set A QK, B QL, and then please substitute the A and B right over here and copy, just copy. So this is 0, this is 0 because they belong to different set, but this one is delta IK and this one is delta Li. So you apply the property of delta. They look at this I over here, and in this case you take off this one and just set K over here. So this is minus, you see, this is minus. Minus comes from here. Then the Poisson bracket of QK, QL is minus delta LK. But usually the Poisson's bracket convention has only positive chronic delta. It's a convention. So then we absorb the minus sign accordingly. You see, that's it. That's an important concept, important result, okay, about the application of the Poisson bracket.